In this problem we have an application to deal with. The very first step of any application process is to try to summarize our information that's given to us in a picture. And I think this problem is a very good example of that process. So we're told that a hot air balloon is released at 1 o'clock and rises vertically at a rate of 2 meters per second. So let's draw a picture of what that could look like. There's the ground. We have some hot air balloon that's rising at 2 meters per second from the ground. An observation point is situated 100 meters from a point on the ground directly below the balloon. So there's some observer here that is 100 meters away from the bottom of the balloon. So 100 meters. T denotes the time in seconds after 1 p.m. Express the distance d between the balloon and the observation point. So this distance here as a function of time t. So let's play around with this a bit. We have a distance between the observer and the balloon told to us to be the value d. We have the distance between the observer and the base of the balloon to be 100 meters. Let's see if we can figure out what the height of the balloon is. So, as a warm-up, after 5 seconds, how far do we think the balloon has traveled? So if t equals 5 seconds, we know that height is going to be, well, it's traveled 5 seconds. It's going up at 2 meters per second. So 2 meters per second times 5 seconds would be a total height of 10 meters. So we can see that the height of the balloon is given by multiplying the speed at which it's rising, 2 meters per second, times the time it's been in the air after 1 p.m. So this distance here is actually known to us to be 2 times t, which means that because this forms a right triangle, all these distances are related by Pythagorean theorem. So here we're going to use the Pythagorean theorem, which states that a squared plus b squared equals c squared, where c is the length of the longest side of a right triangle. A and b are the lengths of the other two sides. So in this example, a would be 100 squared, b would be 2t, quantity squared, the whole thing squared, equals d squared. And now if we read the problem again, it's asking us to express the distance d as a function of t. So as a function of t means that we need to solve this equation for d equaling some expression involving t. In order to solve this equation for d, all that's left to do is to take the square root, to undo the square here. So we take the square root of 100 squared plus, and now we can distribute the power, so 4t squared equals d.